Hi guys, and welcome to our new video. Welcome back. The topic for this video lesson is all about scientific notation. We're going to learn what scientific notation is, how to use it, how to format numbers in this way, and also how to perform operations using scientific notation. So we're going to talk about adding, subtracting, multiplying, and dividing numbers in scientific notation as well. To begin, what is scientific notation anyway? So scientific notation, a number is written in this format when there is a number that's greater than or equal to 1, but less than 10, and it's being multiplied by a power of 10. So any number between 1 and 10, but could equal 1, but can't equal 10, can equal 1, be between 1 and 10, but not equal 10. And then that number is multiplied by a power of 10. That's what we call scientific notation. So as you can see here, there are a few examples of what scientific notation looks like. So the following numbers are written in that format. We have 5.4 times 10 to the third, and then 8.013 times 10 to the negative 6. And you will notice that these numbers in the front, the 5.4 is between 1 and 10, and so is the 8.013. Okay? Now that we know what scientific notation is, let's talk about how we can write numbers in this way. So let's first talk about numbers greater than 10. If we have a number greater than 10, we can move the decimal point to the left to make the number be between 1 and 10 like we need it to be. Then all we need to do is count the number of times we would need to move the decimal and write that as an exponent over a base of 10. And then finally, we write our number multiplied by the power of 10. Now, I know written out and hearing it, that might not make a lot of sense, but of course, we're going to do an example to show you exactly how that would work. So in our first example, we have 604,000. We want to write that in scientific notation. Now, clearly, this number is not between 1 and 10. So let's just talk about the portion of the number that would be able to rewrite between 1 and 10. I'm going to look at the portion of the number that doesn't have a series of zeros. Okay, so I have 604 is the portion where the zeros aren't. That's what I want to turn into a number between 1 and 10. So I will put 6.04. And I want to also put that decimal in the same place on the original number. Now that I have that decimal there kind of as a placeholder, I'm going to count exactly how many decimal places I need to move in order to get the number that I originally had, which was 604,000. So I would be moving the decimal 1, 2, 3, 4, 5 places to the right. So that means I can multiply the 6.04 times 10 to the 5th power because I moved it 5 decimal places. And since I'm moving it to the right, my 5 exponent is positive. Therefore, 604,000 in scientific notation is written as 6.04 times 10 to the 5th. That's the process when we have a number that is greater than 10. Now, let's talk about writing numbers less than 1 in scientific notation. If we have a number less than 1, we're going to move the decimal point until we get a number that's between 1 and 10. That is a requirement that we have to follow. Once it's between 1 and 10, we're going to simply count the number of times we would have to move the decimal. And that number of spaces is becoming a negative exponent on our 10 this time. So if we look at this example, we're given the number 0.0058. If we want to write that in scientific notation, we want to focus our attention on the numbers that don't include the series of zeros. So we'll be focusing our attention on the 58 or the 58. Well, obviously 58 is not between 1 and 10, so we're going to place the decimal in the appropriate place to make this be between 1 and 10. So that would make it be right here. The decimal has to go between 5 and 8. Now, let's count the number of decimal places it would take to get back to the original position. So that would be 1, 2, 3. But this time I moved my decimal to the left, and therefore I have a negative exponent. Okay, so when we have a number that started out less than 1, our exponent is going to be negative. And when we have a number that is bigger than 10, our exponent will be positive. Okay, so 0.0058 written in scientific notation turns out to be 5.8 times 10 to the negative 3. So let's do a few examples to make sure that we completely understand this process. Here we have a very large number, a number much bigger than 10, and of course we want to focus our attention on the numbers before the series of zeros. And if we focus in here, we have 2,456. We need to turn that into a number that's between 1 and 10. So of course I'm going to put the decimal right after the 2. So 2, 4, 5, 6. And if the decimal is there, how many decimal places does it have to move in order to get back to the original number? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this answer is 2.456 times 10 to the 11th power. So it looks like I typed a variable instead of the multiplication symbol, and it wouldn't take our answer. So now that I have updated that to the dot, now let's check and see. And we got it correct. Let's go on to another example. This time we have a number smaller than 1. And once again, we want to focus our attention on the portion that doesn't have the series of zeros. So we have 2,077 if we only focus there. We need to turn this number into a number between 1 and 10. So let's place the decimal here. Now if the decimal is there, how many places do we have to go to get to the original decimal location? 1, 2, 3, 4. But since we went to the left this time, it would be to the negative 4 as our exponent. So typing that in would be 2.077 times 10, and the exponent is negative 4. And let's check it. Awesome. So I'm going to let you guys try a couple on your own. I'm going to give you 30 seconds to come up with the right answer. This time we're being asked to take a number from scientific notation and write it in standard form. So we're going in the opposite direction from before. It's giving us an answer in scientific notation now. So we want to rewrite this number without this power of 10. So simply locate the decimal, and if it's a positive number, you're going to move the decimal that many places to the right. So we start with 9.647, and we're going to move the decimal 7 places to the right. 1, 2, 3, 4, 5, 6, 7. So now the decimal is here, and we need to fill in these extra places with zeros. And we can put the commas so that it's easier to know this number. So 1, 2, 3, comma, 2, 3, comma. So this number is actually 96,470,000. And that's what we need to type in. We will do this again, but this time our number has a negative exponent, and this time we will be moving the decimal place to the left because it's a negative exponent. So once again, start out with the given number, locate the decimal, and move it the appropriate number of places to the left. So we're only going one place, and we stop. So our new number is 0.1588. And that is the introduction to scientific notation. So actually, before we get into arithmetic with scientific notation, and when I say arithmetic, I mean adding, subtracting, multiplying, and dividing numbers that are in scientific notation format, we're actually going to do a few more examples just to make sure you really got it. So we have the notes here on the screen, the simple 3-step process to change a number from standard form into scientific notation. So the first thing you want to do is to focus on those non-zero numbers, or focus on those digits that don't have consistent zeros. And so that would be, for this problem, 3868. So I'm going to focus my attention there. Once my attention is on those numbers, I move on to step 2. I need to change this highlighted number into a number between 1 and 10. Right now, I see 3,868 in my yellow box. To make this number be between 1 and 10, I need to strategically place a decimal so that it will be between 1 and 10. So I'm going to put the decimal here, right after the first digit. That turns the 3,868 into 3.868, and clearly 3 point anything is between 1 and 10. So we're ready to move on to the third and final step, which is to move the decimal to the original location but count. So the original number was 3,868,000,000, and there was an invisible decimal right here, right at the back of the number. So we're going to move it and count 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So now we have all the information that we need. Remember, we said we would type that focus number in, 3.868 times 10, and the 9 that we got from moving and counting, that is the number that becomes the exponent on the base 10. So our 9 goes right here. So simple 3-step process for changing a number from standard form into scientific. Okay. Now let's see an example where we have scientific notation and we're changing it into standard form. We're actually going to go in the opposite direction of the notes that we have here. So it's almost like just going backwards. So let's start with number 3. We use that exponent, the 7, to move the decimal and count. Okay, that 7 tells us how many spaces to move, how many spaces to count, and it also gives us the direction that that decimal should go in. So since this 7 is positive, we would be moving it from right after the 1, we're going to be moving it 7 places to the right. So move and count. 1, 2, 3, 4, 5, 6, 7 would end up right here. And now we're not necessarily making the number be between 1 and 10, but we are going in and filling in the zeros. Okay, so you'd fill in the zeros. And then the last step is simply to just write your number. So the new number is 1304,000. So that's actually what, 13,040,000 would be our final answer. Okay, so now at this point, we will move on to arithmetic with scientific notation. adding, subtracting, multiplying, and dividing numbers in scientific notation. So here is our first example where we will be multiplying and dividing numbers in scientific notation. So we can clearly see this is a multiplication problem because we are multiplying 940 times 2 times 10 to the third. So we have a number in standard form times a number in scientific notation. And that's okay because when we're multiplying things, we can just multiply, in any order. I do like to multiply my regular numbers first, like 940 times 2, we'll do that, and then we'll deal with the 10 to the third power. So 940 times 2, you can do a little scratch work on the side, or you can use a calculator, but that comes out to be 1880. And so we've taken care of the 940 times 2, but the times 10 to the third is still there, so let's put it back there. Now remember, this question asked us to give the answer in scientific notation. And we might be thinking, well, aren't we done? Well, let's look closely. We have 1880 times 10 to the third power. It kind of looks like scientific notation because we have a number times 10 to a power. But remember, the number in the front, the number here, had to be between 1 and 10, and clearly 1,880 is not between 1 and 10. So this is not scientific notation right now, but we can easily fix it. So what I like to do when we get to an issue where it looks like scientific notation, but it's really not, I like to turn it back into standard form. Just take it back to a regular number and then put it in the right way. So what we have here with 1880 times 10 to the third, we have an invisible decimal right here at the back. So let's write it over here just to keep everything neat. We have 1880 invisible decimal that I'm going to make visible times 10 to the third power. We know the exponent tells us how many places to move the decimal and which direction. Positive 3 tells us to move it 3 places to the right. So 1880 moving 1, 2, 3. This is where the decimal should be, and filling in the zeros. So this is the number in standard form. 1880000. That's our standard form number. The question asked us to put it in scientific notation. So now we'll just go through our 3-step process and put it into scientific notation. Focus on the numbers. Make the number be between 1 and 10. So we're going to make this be 1.88. Move and count. 1, 2, 3, 4, 5, 6. So 1.88 times 10 to the positive 6 because we went to the right. This is our answer in scientific notation. Are they mathematically equivalent? Absolutely. They are. But technically the answer in red is not scientific notation. So that's why you would not turn it in that way. So 1.88 times 10 to the 6th power is our final answer. Okay, let's do another one. So for example 2, we have a division problem. We're dividing two numbers that are in scientific notation. We have 1.5 times 10 to the 5th divided by 5.0 times 10 to the 1st power. So when I do a problem like this, once again, I'm going to start by focusing my attention on the regular numbers. So the 1.5 and the 5.0. We're going to actually do that division now. 1.5 divided by 5. And we do have a calculator option here, so we will use it. 1.5 divided by 5.0, which is just 5, gives us 0.3. 0.3. So we'll go ahead and put that down. Now we'll move on to the base 10s, our 10 to the 5th power and our 10 to the 1st power. So you have to think back to our exponent rules, and if you need a recap on that, I will pin that video here, but we talked about exponent rules. If they have the same base, you can subtract the exponents. So these both have base 10, so we subtract 5 minus 1 and get 4. So what we really have is 0.3 times 10 to the 4th power. Okay, so we've done the math, the scratch work, and we just need to check now, is our answer really written in scientific notation? I mean, it looks like it. We've got a number times a power of 10. Well, remember, the number in the front has to be between 1 and 10. This is not. 0.3 is not between 1 and 10. So I advise us to take it all the way back to a standard form and then place it in the right scientific notation. Okay, so this is all a good practice of taking numbers back and forth between standard and scientific so that we can get this right. So we're going to move the 0.3, we're going to move that decimal 4 places to the right. 1, 2, 3, 4. So really the number is 3,000. How do we change 3,000 from standard form into scientific notation? Well, we focused on the numbers that aren't 0, right? The 3, but 3 is already between 1 and 10, okay? And now we move the decimal from here. Why is it there? Because that made the number be between 1 and 10 if we use 3. So going 1, 2, 3 to the right means this answer is 3 times 10 to the 3rd power. 3 times 10 to the 3rd power is our answer. Exponent. Okay, let's do a few more. So once again, let's start with the regular numbers. We do notice that this is a multiplication problem, so we can multiply in any order. I choose to multiply my regular numbers first. So 9.5 times 4.0, I'm going to do first. And then, of course, I have the 10 to the 6th times 10 squared here, but we'll deal with that in a moment. 9.5 times 4.0, we can use our calculator here for easy calculation. Wait, make sure you actually type it in correctly. 9.5 times 4. That gives me 38. Okay, so let me write that down as the answer to the first portion. Now we can move on to the other parts, the base 10s. Remember, exponent rules, when we multiply something with the same base, we can just add the exponents. So 6 plus 2 would be 8. I'm able to do that because we were multiplying this time. Okay, so I have 38 times 10 to the 8th. The last thing we do is check to see if this is real scientific notation. And it's not. Why? Because we have 38. 38 is not between 1 and 10. So what am I going to do? I'm going to take it all the way back out to standard form and then put it in the correct scientific notation. So 38 has an invisible decimal here. I'm going to move it 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. Filling in the zeros. Okay, that's the real number. Changing colors here to quickly get our new answer in scientific notation. 3-step process. Focus on the numbers, which are 38. Change it to make it between 1 and 10 means I need a decimal after the first digit. 3.8 is what I need. And now I'm going to recount to get to the correct location. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. The correct answer is 3.8 times 10 to the 9th power. That's in real scientific notation. Okay, let's do one more that you can try on your own. So for this last example, it is a division problem, and we will start with the numbers once again, our regular numbers. So we have 1.88 over 2,000, or 1.88 divided by 2,000. Let's go ahead and do that first. 1.88 divided by 2,000. And that gives us 0.00094. So we'll go ahead and write that down. And then we will, of course, deal with the base 10 power, which there's only one, so we can just write it down, times 10 to the 6th. So at this point, just like we've been doing, you want to check and see if this number is in scientific notation right now, because if it is, then you're done. And if it's not, you're going to have to fix it. So 0.00094 times 10 to the 6th, unfortunately, is not scientific notation. Why? Because this first number is not between 1 and 10. It's smaller than 1. It's not going to work. So in order to fix it, let's convert it into standard form. Practicing yet that skill again. So we want to move the decimal 6 places to the right because that's our exponent. So we're moving 1, 2, 3, 4, 5, 6. And then of course you got to fill in the 0 here. So this real number is 940. 940 is the real answer. And you might be tempted to just write that down because it's not a super large number, but the instructions say write your answer in scientific notation. So that's what we're going to do. So we're going to go again and change 940 into scientific notation by following our 3-step process. Number 1, focus on the numbers that are not 0, so 94. Now change that number into a number between 1 and 10. So you have to make yourself a decimal right here. And then last step is to move it to the original location. And we know the original was back here. So we're moving it 1, 2, and we're done. Our answer is 9.4 times 10, 9.4. Let's get that right here. Okay, 9.4 times 10 to the 2, because we went 2 to the right. That's a positive 2. That is our answer. Hopefully you got that right, and hopefully you have a better understanding of multiplying and dividing numbers in scientific notation. Stay tuned. We're going to move on now into adding and subtracting. Okay, so now we're going to get into adding and subtracting numbers in scientific notation. And here we have a little bit of a trick to it, so pay close attention. Unlike multiplying and dividing, where your bases of 10, your powers of 10, I should say, could be anything. They didn't have to match. That was perfectly fine. But when you are adding and subtracting, your powers need to match. So that's the first thing you want to do is check your powers and see like what you have. So we have a 10 to the 6th and we have a 10 to the 5th. So clearly they are different. That's a problem. We need to make them be the same thing. So you have a choice here. You can either make the 6 become a 5 or the 5 become a 6, whatever you want to do. I'm going to go through the process to turn the 10 to the 5th power into a 10 to the 6th. So let me just focus on the 4.3 times 10 to the 5th. So we need to think about this a little bit. I want this 10 to the 5th to become a 10 to the 6th. So basically I need to add, excuse me, I shouldn't use the word add. We want to multiply this one by 10. That way this 5 and this 1 will become a 6, okay? But you can't just do that. You can't just put the 10 here without reconciling it on this side, okay? So if I multiply by 10 over here, then to make it be equivalent, I need to divide my first number by 10, okay? So In other words, you have to make it stay equal. So if you multiply on one side by 10, you need to divide the other side by 10 because mathematically you didn't really do anything. Multiplying and dividing by the same number cancels. That's why we're able to do it. Okay, so we will multiply the 10 to the 5th by 10, but we will divide the 4.3 by 10. What does that give us? That gives us a 10 to the 6th, because we know from our exponent rules, 5 plus an invisible 1 gives us 6. And then on this end, when we divide by 10, you could use your calculator if you needed to, but if you divide by 10, you're really just moving the decimal place 1 to the left, moving it back. So 0.43. Now I have it all set up. They have the same powers for 10. They match, and now I can really just do my typical math. I have 2.2 times 10 to the 6th, subtracting 0.43 times 10 to the 6th. So now that they have the same thing, all I really need to do is subtract my regular numbers. 2.2 minus 0.43. So when I subtract 2.2 minus 0.43, I get 1.77. And then my 10s to the 6, they just stay the same. I just bring them down. So at this point, I've done most of the work. I'm going to check, just like on the other section with multiplying and dividing, I'm going to check and verify if my answer is written in scientific notation. So I see I have some number times 10 to the 6 to a power of 10, and that's good. And then I check to see if my number up front is between 1 and 10, and it is. So in this case, it's already in scientific notation. We don't have to make it the standard form and correct it. It's already there. So times 10 to the 6th power. Okay, great. So we're going to move on and do another example. So here we have example 2, 7.9 times 10 to the 7th plus 6.5 times 10 to the 6th. So of course we can see this is an addition problem, but the way we tackle it is exactly the same. First, we want to check and see if our powers are the same. Remember, when we have an adding and subtracting, the powers have to be identical. And I have a 10 to the 7th and a 10 to the 6th, which means they are not going to work the way they are right now. Not going to work. So you can choose to either turn the 7 into a 6 or a 6 into a 7. I choose to turn the 10 to the 6 into a 7. And we're going to do the same process just like example 1. So 6.5 times 10 to the 6th. Remember, in order to make this 6 become a 7, that means I need to multiply by 10 here. And if I multiply by 10 there, I need to divide by 10 here to keep it equivalent. So this gives me the 10 to the 7th that I wanted. And over here, when I divide by 10, it's just a basic move the decimal to the left one place. So that's 0.65. So now I'm ready to continue on. Going back to my original 7.9 times 10 to the 7. Since they are identical now, the powers, they both are 10 to the 7. Oh, my circles are terrible. Apologize for that. Come on, let's make that a little better. How about that? So since my powers are now identical, all I'm doing is adding the 7.9 to the 0.65. And that is going to give us 8.55. And you just bring down your power 10 to the 7th. Check now, before you get ready to turn it in, check and see, is this number indeed written in scientific notation? We have a number times a power of 10. But then we check, is this number between 1 and 10? And it is, so we are good. 8.55 times 10 to the 7th power. Notice how in this problem, you have one number in standard form and one in scientific notation. So we can choose to either put the standard form one in scientific, or we can put the one in scientific and standard, work it out, and turn it back into scientific later. But since our answer has to be in scientific, why not go ahead and change this one into scientific notation now? Okay, so 0.0004, remember, focus on the non-zero digit, which is 4. If we change that into a number between 1 and 10, it already is. The decimal's back here behind it. So we would be counting 1, 2, 3, 4 to the left. So 4 times 10 to the negative 4 is the real number there. Okay, so we took the time to change that number into scientific notation, and so we really can start from here. 8.2 times 10 to the negative 5th plus 4 times 10 to the negative 4. So we're really starting here. And from here, we need to know, do they have the same powers for the 10? And they don't. This one is to the negative 5th, and this one is to the negative 4th power. So we know anytime we're adding or subtracting in scientific notation, those numbers need to be the same. So we can either change the negative 5 to a negative 4, or we can change the negative 4 to a negative 5, your choice. You probably have noticed I've been doing a pattern of making my numbers get bigger. Like I went from 4 to 5, then I went from 6 to 7. So same thing here. I'm going to take the negative 5 and turn it into a negative 4. So that means I'm going to use this one. 8.2 times 10 to the negative 5 is going to be my choice of one to change. And if I want that negative 5 to go up, right, up to negative 4, then I need to multiply by 10. And you know, if I multiply by 10 here, then I have to divide by 10 here. So my number becomes 10 to the negative 4. And over here, the number goes back 1, and that's 0.82. Okay, so I'm ready to start my problem from here. I have 0.82 times 10 to the negative 4 plus 4 times 10 to the negative 4. And you know, when we do that, we can just combine the numbers. So 4.82, because 4 plus 0.82 is 4.82 times 10 to the negative 4. And I can check from here, is this already in scientific notation or not? Well, it looks a lot like it. So check and see if the number in the front is between 1 and 10. And it is as well. So we're finished. We can just type our answer in. 4.82 times 10 to the negative 4. And you can see that a little better if I clear the screen. So let's clear and check our solution. Okay, let's do one more example. We have 4.9 times 10 to the 4th minus 8,200 or 8,200. Once again, let's change that standard form number into scientific notation so that we can see what we really have here. 8,200 in scientific notation would be 8.2 times 10 to the 1, 2, 3, third power, okay? And we can see those bases, those powers of 10 do not match. We have 10 to the 4th and 10 to the 3rd, so they don't match. So we need to make them match first. Remember, I like to make my powers go up. So I'll go ahead and multiply this one by 10 so I can get that 10 to the 4th, and I'll divide this one by 10. So it turns into 0.82, that looks familiar, 0.82 times 10 to the 4th. Okay, so now they match. So we have 0.82 times 10 to the 4th, and over here 4.9 times 10 to the 4th, and this time we are subtracting. Now that the powers of 10 are the same, all we need to do is subtract the 4.9 and the 0.82. So we end up with 4.08 times 10 to the 4th power. And then we check, we need to verify, is this scientific notation? Again, it looks like it. We have a number times the power of 10. Is that number between 1 and 10? Yes, it is. So we are done. 4.08 times 10 to the 4th. Okay. Really hope that this video has been helpful for you. We talked about numbers in scientific notation, what scientific notation is, why we use it, how to convert between standard and scientific and back and forth. We talked about multiplying and dividing as well as adding and subtracting. Okay. I hope again that this has been helpful, and we will see you in the next video.